Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks. Geeks for Geeks has a challenge for you, the 390 challenge. Choose what you want to learn in 2024 and aim to complete at least 90% of the course in the next 90 days. And if you do that, you get back 90% of what you paid for the course. We believe you can do that. Now all you got to do is commit to your success, commit with Geeks for Geeks.
Hi, and welcome to Geeks for Geeks. I'm Siddhartha Hazra. I'm an SD at Geeks for Geeks. Besides that, I'm a candidate master at Code Forces, and I would be the person who would be doing the post contest analysis of today's contest. So let's first talk about the feedback I have from this. Okay, so if you were a person who is very good with dynamic programming, the concepts like recursion and backtracking, then 2 out of 4 questions were can be taken down. One was a simple simulation based question, and the last one was a comparatively good one with constructive algorithms at its peak. So I would discuss the last contest in very detail, and let's start from the very first. So just let me know if my audio and video is fine enough or not. Okay, just quickly tell me if these things are clear to you or not, and then we would start right away. Okay, fair enough. So if my audio and video is kind of getting lagged or something, just quickly let me know, else I would move forward with the today's stream. Okay, so let me first, today I would explain the code. Okay, just a simple sec. Fair enough. Let's move back. Let me just do this. Yep. Thank you so much, Nipan. And let me just share my whole screen. Last one was hard. Yes, comparatively you can say that. But if you understand it is easy. It doesn't require any complex algorithm, to be honest. Okay, so now let's start with the very first problem, that is check for consecutive. So I won't really go into the details, but the problem asks us that we need to generate a binary string for each of the numbers. Okay, and in the binary string is a string which is made up of 0 and 1s. So let me just copy it. Okay, and then let me just show you. देखो बच्चा, okay, so now this problem tells us what? That you need to build a binary string of the length of the array. So let's first take a binary string of length 3 because the array length is 3. Now, the point is, if a value, let's say the value is x. So if a value greater, that is x plus 1 is present in the array, or x minus 1 is present in the array, either of them is true, then the value here that would gift that would be gifted down is 1 in this scenario. If either of them, like both of them are false, if both of them are false, then the value would be 0. Okay, now let's see this. If this is the value 3, now if the value 3 plus 1, that is 4 is present, no, 4 is not present. 3 minus 1, first we would check for this condition. If this condition is not true, we would check the next condition. If 3 minus 1 is present or not, that is 3 minus 1 is 2, yes, 2 is present, the value here is 1. Next we go to the next string, that is 2. We would check for 2 plus 1, 3 is present, so we would go down from here itself. Okay, then we check for 7 plus 1, 8, is 8 present? No. 7 minus 1, that is 6 is also not present. Both of these conditions are false, so we would say a 0 in the chart. Okay, so now the point is that we would simply ask at each point if these two values were present before or not. So you need to either search that element. So to search that element, the time complexity would be big O of n. But as we need to search multiple elements and those elements belong from the same thing itself, like अगर मुझे पता है, okay, let's say I want to know, like I want to search an element, let's say 5, 10, 9, then linear search is okay or binary search is okay. But here, if you observe the values, but like we just want to know if this value is present in the array or not. So if we want to know if the value is present in the array or not, then we can simply remember all the values in the array, and then we can just check if we have seen this or not, if we have seen this or not. So whenever you come to the conclusion in DSA that you need to remember anything, then this you need to hash those values or use hashing or hash map or math. Okay, so the idea is very simple. Okay, the straightforward thing. Okay, so I would just show you the code itself at this point. So see, we declared a map of integer and integer. Okay, and then we just hashed all the values, and then I initialized a string of length n with all the values at 0. This just means that if n is equals to 4, let's say, then the values would be 1, 2, 3, 4. And the values, then this string would be of length n with all the values as 0. This just means this. Okay, now for each of the value, if I'm not able to find this, if this is true, that means if x minus 1 is present or x minus plus 1 is present, we would write it as 1. Else 0 is already there, so we won't touch it, and then we would return this. Then we would return this as itself. Then we would return this as itself. Fair enough? Makes sense? I would just float this down. So quickly tell me if things are clear to you or not. I would generate the URL and share it with you all. Okay, let me read the comments at this point. So just quickly give me a 0 or 1 if things are clear to you or not. For every time my code limit is exceeded, I am unable to solve even as correctly. Time limited today. Okay, it's okay. How many? Okay, which solves that question contest? And can you please tell the code in Java? This algorithm is giving. This algo gave a time limit exceeded in Java. No, I used some and passed. So I have the admin access. So let's just see this, if this is true or not. All summation and then Java. Okay. Has set of integers. She has added ordinal numbers. And then if this number is present, append 1, else append 0. Yep. So I think this makes this difference, string builder, because as far as I know in Java, the string class is a mutable and non-immutable thing. So if you add that string, it just declares a new string with the new values. That is, I think, so this is the reason. Can anyone confirm? Because I'm not that much proficient in Java, but I know this, that the general string is immutable, okay, and this is mutable, or the vice versa. This is the scenario. That is why the string builder approach is giving a AC. Can someone confirm if I am correct or not? Just quickly give me a 0 or 1. I think so this is the error. Collections dot sort s plus this string. Yes, I think so this is the error, because string is mutable or something. This is makes the difference. Quickly, just can someone tell me if I'm correct or not? So, Pawan, can you quickly confirm the reason? Yes, see, I told you, no, this is the reason. Okay, you string in Java. I think so. String is why, because if you add a new character in a string, then it generates a new string. Okay, this generates a new string. I think so. This is the scenario. Okay, yes, just tell me all your doubts. So I think so. This. So am I clear with this approach then? Quickly give me a 1 or 0. Can I move forward? Quickly give me a 1. I think so. I can move forward. String in Java is immutable. Yep. Okay. Fair enough. Let's go to the coin distribution. Mhm. I think so. Java is comparatively a very like strict programming language. You need to know small things, buffer reader, scanner, and these all things. Back in those days when I used to do Java a lot, I stood. Okay, so fair enough. Let's move forward to the next problem, that is coin distribution. Okay, so now this problem is again a small variation of a very famous problem, if you observe. Okay, so you are given n strings in an array, where array a of I represents the value of the string I. Okay, and you want to find all the distinct way to distribute exactly r coins. Okay, so let me just tell you at this point what this is. Okay. Okay, fair enough. This seems to be on the easier side if you observe. Why? Because see this. Okay, सब easy है, बस समझने का खेल है. Okay, well, today's contest was everything all about समझने का खेल. Okay, I think so. Okay, so see, देखो बच्चा. So we have 2, 1, 3. Okay, let's say I have 3 chocolates. Okay, that is 1, 2, and 3. Basically, let's say 1, 2, 3 chocolate. Now, how many ways I can make a group of 2? This is what is asked. Okay, so first what I can do is I can take this 1 and take this 2. Then I can take, so if I do this, I would get 1, 2. Okay, so now let's not write it again and again. So I can take this and take this. That is why 1 2. Then I can take this and take this. So 1 3. Now I can take this and take this. Simple enough. Now, what is the question that is asked? The question that is asked is find all, I can say subsequence, can say subsequence, because that also respect the ordering, but here the ordering is also not respected. I can say kind of subsequence. So basically आपको क्या करना है, दो values चुनने का तरीका, like combination. This is simple enough, like 3C2. Okay, number of ways to select two elements from three items. 3C2, see the value would be 3. Okay, the value would be 3 for 3C2. What is the value of 3C2? Okay, 3C2 value. 3C2, 3C2, where is 3C2? What is 3C? What is 3C2? 3. Told you, no? 3. That is why number of ways to select two items from 3. Okay, so this is what is asked. Now you need to report all the values. Now see, this gives me that I need to report all kind of combinations or permutations. Kind of. I need to report all types of combinations. So the time complexity would be very, see, I need to try all possible ways. All possible ways जब भी आ जाती है in programming, we should think of recursion. Now, recursion has a very high time complexity, Siddharth. Okay, should I move in this fashion or should I think of something else? No. When you come down in the constraint, you see that the value is 20. And as far as my experience is concerned, for the last 5 years, whenever I see a question that is that has the constraint, the size of the array is less than equal to 20 or 18 to be specific, 8 out of 10 question it is of recursion or backtracking. How I claim this? Let me make you clear that also. See, in 1 second I can do 10 to the power 8 operation in an online judge. That is why whenever we see this, that is 2 raised to the power 20, because most of the times recursion has a exponential time complexity. If you observe, this value is less than 10 to the power 8. This is approximately 1 2 3 4 5 6. This value is 10 to the power 6 or 7. Okay, this value is less than 10 to the power 8. So exponential solution would pass over this constraint. यहीं से मुझे पहले ही समझ आ जाता without even reading the question that what kind of algorithm should be used. अगर आपको यहां से भी कोई आइडिया नहीं आ रहा है, it's fine. You don't really need to worry about this. Okay, अगर आपको यहाँ से भी खास कोई फायदा नहीं आता है, समझ नहीं आता है, तो ये मुझे कैसे पता होगा, मैं तो न्यूबी हूँ, मुझे खास कुछ पता नहीं है. Just remember this, when the constraint is very small, that question is a backtracking or recursion. I claim this. Okay, fair enough, no issues till this point. Now, this what makes the difference. The difference that is made is this test case. Okay, ये काफी प्यारा सा टेस्ट केस है, एकदम क्यूट सा टेस्ट केस. देखो, and this opens the door. See, need to divide two elements. So that is why if you draw out all the consecutive different values, then after taking out the distinct, this would be the value. Okay, but distinct is making all the difference. How to tackle this distinct thing, Siddharth? Okay, for tackling this distinct thing, okay, I would sort this array. I would sort this array. Now, I would treat this number as a single number kind of thing. Treat this number as a single number kind of thing. Now see, I would take this value. I need to take two values, no? And then I would take one value from here because I considered it as a single number. So 1, 2. 1, 2 is here. Then one value here and one value from here. Why? Because I consider this as a single element as of now. That is 1 and 3. Fair enough. Now, I consider this as a single element and this. So 2 and 3. And at the end, when everything is done, I write those two elements also. Okay. Now, let us see one more test case. 1, 2, 2, 2, and 3. What difference does it make? See, I would take this number and this would be treated as a whole. Same elements, treat it as a whole. Here also, if you observe, I would take this value and this value because need to take two values only, this value and this value. So 1 and 2. Then I take this value and this value because I treat this as a single number. So 1 and 3. Then 2 and 3. Okay. And at the end, just insert 2 and 2. So the idea is to treat the same numbers as a single number. Okay. The idea is to treat the same numbers as a single number. Okay. Now, what I would do is, I would simply see, let's say I have taken up this value. Okay. And then I have taken. So as of now, the idea is for distinct thing. Okay. So now, first let us solve this question for just 1, 2, and 3, where we don't have any duplicates. अभी वहां चलते हैं जब डुप्लीकेट बोल के कोई राक्षस नहीं है. Okay, fair enough. Okay, fair enough. Now what we would do is, let's say we need to select two elements. So we would start from here, take this value, that is 1, and the number of values that is remaining would now be 1. And here we would go to the next element. We won't include 1. Okay, here 1 is taken, here also 1 is taken. Then here 2 is taken, here 3 is taken. And then after this, we would do the same thing. From 1, I did 1 and 2, 2 and 1 and 3. Again, from here, I would stand at 2 and I would select 3. And then I would select the consecutive values if they are. Now, stand at this, select the next number. Stand at this, select the next number. Okay. Now, what I want is, please listen this carefully. What I want is, the only difference that it makes is, I want this and then I want this, but I don't want this. So what I can simply do is, if previous is equals to current, because I want to consider them as a single element. If previous is equals to current, I would simply say skip. So skip in DSA is continue. Break and continue pada hoga na. Skip is continue. So the code remains the same. Now you would say how to find all the different permutations. That is the first level base of this question. So I would say consider solving permutations of a string. Okay, and you would have a proper base for this question. Ab tum bologe, Siddharth, how would I have this idea in my head in the very first way? So basically this is not meant to be that much intuitive. This is kind of a variation of this problem. Find all permutations of a string. Consider solving of this problem. This problem is very much important in terms of interview, in terms of recursion. So if you see the company tags, it is hell lot, and it has been solved by more than two, like 1/4 of a million. So I would no this would act as a base for that question. Like if you observe the here, you just need to print all the permutations. Okay, this would act as a base for that. Here also, if you observe, print all the unique permutation. Here you would get the idea, because if you see the solution here, see, this is a very famous question, and if you see the solution here if itself, okay, let me just show you some of the solutions. Alternative approach, देखो मैं दिखाता हूँ. Okay, just see the solution. Here also we do the same thing, that if the next element is equal to the previous, we simply skip. Okay, this same idea is used in this question for getting the unique permutation. Okay, so the idea of this is this one. What we would do is we would first sort the array so that equal elements can be treated as a single element. Then I declare a result array, and then when the number of elements that needs to be inserted, what is R basically? What is R? I would tell you that. Damn. So R here is the number of values that needs to be put in. So if all the values are put in, I just insert that permutation, kind of not permutation, subsequence. Okay. Now, if the current element is equal to the previous element, I just simply skip. Now what I do is I insert the current element, and then I move forward to the next index, and then I subtract that. Yes, one value has taken, one value has been taken, and remaining values are -1. So I do that, and when the work is done, I just pop back. This is a basic backtracking approach. The same thing is here. You can take inspiration from this. So let me just see. See, first I swap it, then I do a recursion forward, and then I swap back again. This is a backtracking approach. Okay, just as. So I would explain you more on this. Okay, why, how would I get, like मुझे अगर पूछा जाए ना तो मुझे रिकर्शन वाला आइडिया आ जाएगा, बट ये जो छोटा सा पॉइंट था ना इन माय इनिशियल डेज, this thing bothered me a lot. How would I get to think of that I need to insert the element? Then next time after the work is done, I need to pop back. What is this? Okay. So now let me explain this small point where I stepped, okay, in my initial days. Okay, ये जो होता है ना थोड़ा सा अजीब सा होता है. So now see, what happens is, this is a recursion. This is a recursion. My screen is shared. Okay, this is basically recursion. So I take up this value, then I take up this, let's say I take up this value, and then I take up this value. Okay, let's say two values. Okay, R is equals to 2. No? Let's say R is equals to 2, and initially I take 1. So here R is equals to 2. Initially 1 is taken, so R remaining would be 1. Then I take again 2, so R remaining would be 0. So when R is 0, I insert this. But this is a vector. I need to use the same vector after this work is done. This is just like my roommate. This is me. I would tell you what is being done. This is me and this is my roommate. Let's say he wants a chair from my room. So he came to me, asked for my chair. I told him, okay, use this chair. After your work is done, put it back again. That is, put it back again. Same thing goes for here. I use up this vector to build up my answer. After the answer is built and r is equals to 0, I insert that. And then I say, okay, now remove all your elements. I need to do the work for the next subsequence. This is why after the work is done, we pop back. Let me just show you in practice. Okay, no worries. I just explained a bit. Okay, I would explain again. देखो बच्चा ध्यान से देखना. I would explain the last statement again. देखो, what happens is, what I say is, see, initially r is equals to 2. I take up this element and then r becomes 1 because every time I take an element, r is equals to r minus 1. Then I take up this element, that is 2. R has now become 0. So I would insert this vector. So now for the next subsequence or for the next answer, I need to use the same vector. So we are popping back. Let's understand this in a better. Let's understand this in a okay. Let's understand this in a better fashion. Let's understand this in a better fashion. So let's say this is me and this is my roommate. He wants a chair from my room. I say, okay, use up this chair. When you're done, put it back again. So that is why I use up this vector. When I'm done with the recursion, I say that okay, now clear the area. This is just like this. Okay, just do the dry run on a pen and paper, then you will understand. See, first I insert this element, then I complete the recursion. After this recursion is complete, then this line would execute and remove the elements. That is why we can use the same simple array to build out all the combination. This is why this concept of pushback and popback is used, and this is how they are functioning. Okay, now let me just float you again. Anyone has any concern or queries? Quickly tell me at this point. Else I would move forward to the next question. Because the last question would take time. To be honest, a good amount of time would be taken. Okay. Now tell me if the question is clear to you or not, or you need more explanation. There are 23 people. I can expect at least 10 zeros and ones. If you want me, if you have an issue or something, consider telling me the issue. If you're good moving forward, give me a quick one so that I can simply move forward and everyone can just go away. I mean, if there is any way to check the contest solution after the completion of the question, you have to wait till then you can get editorials. So the thing is, you need to check on your end because I have the admin access and can't really tell you, but you can see it. Okay, let's move forward to the last question, third last question, second last. Sorry. Okay. This question is also, I can say, a variation of a very famous problem. Very famous problem. So this was a variation of permutation, okay, or choose a subsequence, and this is a variation of this. That is coin combination. Okay, there you can just find this coin combination everywhere. Coin change, coin combination, coin change, coin combination. This is present in all the platforms. Okay, this is the problem. So this is the coin combination 2. There are three ways, three. Yep, this is the problem. This problem is wrapped over this problem. Okay. So now, before I start off with this question, let us first understand this question and then we would go back to that question. Okay. So here, in this question, let's first understand this question and then we would go back to this question. This question would act as a base for that question, because that has a big problem statement. We would decode it, to be honest. So see, what is asked here? It is asked that we have a set of available okay, fair enough. So we have 3 and 9 here, and this is 2, 3 and 5, and the solution is 3. So what is this asked? 2, 2, 3, 3, 3, 3 number of ways, distinct or number of ways using the available coins. Okay, fair enough. Now see what this question basically asks. So see, here you have a particular budget. Let's say you have a particular amount, that is 9. Now these are the different coins that are available, the denomination of the coins. Now it is asking how many number of ways I can build out this value 9 here. Okay, how many ways I can build out this value? Yep, this one. Okay, take this problem. Same question. That question was distant, this question was not distant. Sorry about this. Okay, fair enough. Let's continue. How many ways I can have 2, 3, 5? Okay, how many ways I can have 2, 3, 5 and get the denomination as 9? So there are 9 possible ways, 8 or 9 possible ways. 8. How? I can have 2, 2, 5. Then I can have 2, 5, 2. Then I can have 5, 2, 2. Then I can have 3, 3, 3. Then I can have 2, 2, 2 and 3. Okay. So here the algorithm to use here is that we would first consider a number in our solution, and the next time we won't consider that number in our solution. We would consider 2 to make up the sum 9. Next time we won't consider this number. Okay. Now let's say this algorithm, like this part, needs to be understood. Okay, as of now let's hear a story at this point. इसको रहने देते हैं, मतलब वही करना है मुझे इस डिनोमिनेशन को यूज करके आई नीड टू गेट द वैल्यू दैट इज 9. ओके, नाउ एक स्टोरी सुनते हैं. लेट्स से I have, let's say, like this is me, and there is a brand known as Decathlon. Okay, now what happened was, and this is a brand, let's say this brand is Roadster. Okay, so I went to Roadster and then I decided not to buy clothes from Roadster. So next time also I won't buy because I have decided not to buy Roadster. No? But if I buy Decathlon, then I might also consider Decathlon again. See, if I have decided not to include Roadster in my wardrobe, There is no possibility that next day I would again buy roadster clothes. If I've decided not to buy it, then by no means there is no point to consider it again. But if I have bought some clothes from Decathlon, the next day also I can again buy it. Please remember this scenario. ये scenario याद रखो. This would serve as a base for us eventually. अब देखो. So I have the sum as 9. So if I select 2, then I would have the sum as 7. Okay, by selecting 2 here. So I would just enclose this in the bracket. So let's say by selecting 2, after selecting 2, I got the sum as 7. Here I decided not to include 2. So the amount of money would also remain the same. पहले भी 9 था, अब भी 9 है. पिछले बार मैंने डिसाइड किया 2 को इंक्लूड करना है, तो I included it. Now, if I have included 2, then I can include 2 again. So if I include 2 again, now my sum is 5, and this time 2 plus 2 is included. If I have decided not to include 2, then the sum would remain same. Here in this arena, if you observe, this side we have decided not to include 2. So here I would move forward with the same value, that is 9. Okay. Again, if I have decided to include 2 in this, I can again include 2 now. So I would again include 2. That is 2 plus 2 plus 2, which would make it as 3. And here I have decided not to include 2. Here for this 7, after this value, here we will include 3 and 4. So now let us understand this with a small idea. So see, I would make this test case comparatively small. So see, the idea is simple. Let's say we just include 1 and 2. We just have 2 numbers. And the budget is to make, let's say, 3. First, if I decided to take 1, the remaining sum would be 2. If I've decided not to take 1, the remaining sum is 3. And what value I have taken? I have taken a denomination of 1. So here, if I have taken a denomination of 1, then I might take the denomination again of 1. So if I take the denomination of 1 again, I would land at 1 plus 1. And again, I have used 1 more, so the sum remaining would be 1 here. If I have decided not to take 1, then let's move forward to 2 only. So if I take 2, the remaining sum would be 1, and I have taken 2. If I have decided not to take 2 also, the remaining sum would be 3. Okay. Here, as I am taking 1, so I might take 1 again. Okay. And here I have decided not to take 1. So it would remain as 2. Now, if I take 1 again, the denomination would be 1 plus 1 plus 1, and this would become 0. Okay. Here, if I've decided not to take 1, this side I'm deciding not to take, this side I'm deciding to take. If I've decided not to take 1, then here I would take 2 first. That would make the sum as 0. Okay, that would make the sum as 0. Earlier it was 1, and this is 1 plus 2. So यहाँ पर we took 1, and here we are taking 2 again. Consider 2 again. So that would be 1 plus 2. Here I am deciding not to take 2, so it would remain 2. Okay, this side, I have decided to take 2, but I can't really take more 2's here. So I would simply, 2 can't be accommodated now. So I can simply ignore this only. अगर मेरे पास उतना वैल्यू ही नहीं है, अगर मेरे पास डीकैथलॉन के लायक पैसे ही नहीं है, so I have no option but to ignore it. If I don't have the money to buy clothes from Decathlon, I have no option but to ignore it. That is why if I come here and I get the sum as 2, and I have budget of only 1 only, and I can't really consider it. No? I have the option to only deconsider it. Now, the value is 3, and I have decided not to take 1 also, not to take 2 also. So it remained 3, and I'm out of coins. I am out of coins. Okay. What are the different ways in which 3 can be made using the coins 1 and 2? The ways are, the valid ways are 1 plus 1 plus 1 and 1 plus 2. These are the two ways we can build 1 plus 2. So we can say that a combination is successful. A combination is successful when the remaining sum is 0. This is the point where the combination is successful. Okay. So if I use recursion to solve up this problem, I would say that if the sum remaining, I would simply say if the sum remaining is equals to 0, I would say this is a valid combination. If I am out of coins, that means the index or the coin I am considering is now over, then invalid. So I would say if coins are over, then there is no point in moving forward, just stop. Here this is a valid combination. Makes sense. This is a valid combination, so I would add 1 to the answer. Do I make sense? Using the coins 1 and 2, how many ways I can build 3? By this is the recursion. This is basically the recursion tree of this. Quickly give me a 0 or 1 in the chat. Quickly give me a 0 or 1 if I'm clear till this point. And don't worry about that question. Tell me for this question. Okay. Let's move back. Again, I would just simply swiftly sum up. So देखो यहाँ पे क्या है? I'm trying to build 3 from the denomination 1 and 2. So I have decided to take 1. So sum remaining is 2, and I have taken 1. I have decided not to take 1, so the sum remaining is 3 only. Now I come here, I take 1, and the sum remaining is now 1, so it is 1 plus 1. I do not take 1, so the sum is still the same. Then as I have taken 1, I am considering 1 again. And here for this 2, I am considering 2 again. Here I don't consider 2. Okay. Here for after 3, if I consider 2, it would become 1. After 3, if I don't consider 2 also, it would remain as 3. Then I have no elements after 2, so it would remain as 1. So now from this, what are the valid combination? The valid combination with this and this. So when do I know that this is a valid combination? When the remaining sum is 0. When do I know that I need to stop? When the coin are over. See here, the sum is remaining, but the coins are over. 1 and 2 both are considered. So sum is remaining, but the coins are over at this point. Make sense? Give me a 0 or 1 in the chat. Okay. Now, this question, what needs to be done is, for each of the values, these are the coins. So, this question is just a wrapper over the previous question. For each value, use the calories as coins to build h of I. Can I say this? For building h of I, use the values in the calories to build h of I. And this is what is the solution. For each of the values, use the below number of calories to do this. How can I conclude this? This is concluded in this, that each friend, see, anyone can eat any dish any number of times, including 0. So a person can use a particular denomination any number of times, okay, or ignore it. So this is the point to do this. Now the solution of this is the same. So this is to build up the number of ways a value, number of ways a value each can be built from all the coins. Okay, this is basically the sum that needs to be built. Is my screen shared? Yes. So what I would do is, if the sum at the end is 0, I showed you, no? When the sum is 0, I would say it is a valid sequence. So I would return 1. When the sum is less than 0 or our coins has exhausted, then I would return 0. That this is not a valid combination. Just return from this point. Else, this is a TP thing. You can just skip at this point. Now, else I have two options. If I include up this thing, then I won't move forward in the index. Why? Because if I'm buying the decathlon clothes, then there is a very high probability that I would consider buying decathlon clothes the very next day also. But if I've decided not to buy it, see here I have decided not to buy, then I would simply move forward. As the values are very large, so I'm just doing the modulo operation and each step. This is just like doing a plus b whole modulo, which is equals to a modulo b, a modulo m, b modulo m, and whole modulo m. So I would return this index. Now, what are the values that are moving values? The moving values are h and the index. The maximum value of h given is how much? The maximum value of h given is 10 to the power 3. The maximum value of index is 10 to the power 3. So I declare a 2D array of h multiplied by the index, and I just hash up this. This is how I memorize the solution. I don't detect it as a 1D or 2D array. I just find out the number of dynamic variables, see their range, and declare an array or a map according to the needs. And now for each of the values, I use it as a base to find, just like for each of the values, I call this function to find me the number of ways this can be built. Find the number of ways this can be built. Find the number of ways this can be built. This is what I'm doing. Fair enough? Makes sense? Just tell me the line number at which you're not able to understand. Okay. So anyone has any concern or queries, I would wait for the next 30 seconds and then I would move forward. So in question 3 for hunger, I have computer active. Bhaiya, I'm currently in 12th. Okay. Completed 70 problems. Achieved certification in hacker rank for Python. Now, if I manage to come up in top 100 in this course, should I get any benefit like internship or anything? I think no, because it requires you to have a bachelor degree. But if you are in class 12th and you are doing DSA to this extent, I would suggest you to do competitive programming at this point. Explore the realm of programming, the sports programming, attain titles over there. Like you are in your golden era. Use it at the max, I would say. Okay, fair enough. Let's move forward to the last problem. Okay, last problem is absolutely a beauty in itself. So, did it receive any zeros or something? No queries up till now. So, I would move forward with the last problem. Mhm. So, now see. Let us first understand this question. Okay. Okay. Let us first understand this question. This question is a good one. So you are here in this question, you are given a binary string and you can perform two operations over it. What are the possible operations? Remove some characters from the beginning of the string. That is just like remove prefix. Remove prefix or suffix or both. Like you can remove the prefix or suffix or both. Like you can remove characters from both of the side. This is what is told. Now you can do this any number of times. Okay, like you can do this any number of, like you can do this what how much you want. But what you need to do is you need to minimize two things. That is num0, number of 0 left, and number of 1 removed. You need to minimize number of zeros left and number of ones removed. So now if I have this string 1 0 1 1 1 1 0 1 1 1 0 1 1 0. Okay, if I have this string and if I remove this value, the number of zeros remaining, if I remove these values, if from the front, if I remove this and if I remove this, the number of ones I have removed is 1 and the number of zeros that is remaining is also 1. So maximum of 1 and 1 is 1, and this is how we are minimizing the number of zeros that is left and minimizing the number of ones that is removed. Let us see the very next test case. That is 1, and this test case is the point where I would drive you to the solution. 1 0 0 1 0 0 1 1 0 0 1 0 0 1 and then again 0 0 1 and then again 0 0 1. Now 3. Okay, so now how we can build up the solution for this? The solution of this can be built up in this fashion, that if I remove up till this point and if I remove up till this point, the number of zeros remaining is 2 and the number of 1 that is removed is 3. So maximum of 2 comma 3 is equals to 3. That is why this is the answer. Now see, we need to find the minimum value. Okay, so there are 3 solutions for this. That there can be a greedy solution, there can be a DP solution, as well as there can be a binary search solution. For me, binary search one is the most intuitive one. Okay, why it is? Because is everything okay? Quick health check at this point. Yes, everything is okay at this point. So see this with care. Dekho. Now, why I would think of binary search would work here? Because I have this window thing. Okay, let's say this value is 0, this value is 3, that is for this question, and this value is, let's say, 100. So for all these values the answer would be no, and for all these values till infinity the answer would be yes, and we need to hit the first point of yes. So this shows me that this is a monotonic function, and I can use binary search over here because I need to find the minimum value. So this, if minimum value is this, then I can also do the same thing for my consecutive values also. So I need to find out the first yes position, and this is where I would have the solution. Okay. Now, so now first I need to find the first. So the monotonic function would look something like this. That the maximum answer can be what? The maximum answer can be the number of zeros or ones I can remove. Okay, number of ones I am removing. Okay, so let's say the monotonic function is looking like this. No, no. Okay, let's just write nn. Okay, so monotonic function is no, 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 no. Okay, let's not write no this much, and let's say this is yes, 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 yes. So I need to find what? I need to first find the first position where this is a yes, and this would be the minimum point. So if this is low and this is high, so let's first write the recursive like binary search thing. So if we land at any position of yes, then we need to go here. So we would make high go to mid -1. If let's say the mid is landing me here, अगर mid मुझे इस वाले y पे लाता है, तो मुझे पहला वाला y चाहिए which would be sitting on the left hand side of me. So I would make this high go to mid -1. So I can say if the answer is yes, I would update the answer and I would make high is equals to mid -1. Now, if let's say my mid is landing me in a position of no, then I need to find yes, which would be located on the right hand side. So that is for this I need to make L go from this side to this side. So whenever we have a condition of no, I won't update the answer because we don't want the no condition. I would make low is equals to mid +1. How we are checking if it is yes or no, that is a different question at this point. But first, this is how the binary search would look like. Okay. Now at this point, let us just see the binary search thing. Just the binary search thing. Binary search code. Okay. So lows and highs is low is 0 and high is -1. So if it is possible, then we are making high is equals to mid -1. If it is not possible, we are making low is equals to mid +1. At this point, you don't need to see this thing. So this is the code that I want to show you. You don't need to see anything else. I got the intuition. This is a binary search solution. I know this is a monotonic function, and this is how I would hit the first y. Now the question is, how would I find if the answer is yes or no? This makes the difference. Okay. I should be clear at this point. No queries, the number of people absolutely very less, so I would just keep talking to myself because I know no one is participating at this point. So now see, If let's say I want to remove two ones, I want to remove two ones, then what I can do? I can remove 0 ones from this side and 2 ones from this side. I can remove 1 1 from this side and 1 1 from this side. And one more thing I can do is I can remove 2 1 from this side and I can remove 0 1 from this side. I can have a condition like this. This is just like 0 and this is selecting 2. This is selecting 1 from the 1 1 from this side and selecting 1 1 from this side. Selecting 2 ones from this side and 0 ones from this side. Same goes for 4 also. Let's say for 4, I would select 0 and I would select 4 here. I would select 1. So for 4 also, I would, let's say for 3, let's take for 3. For 3 also, I would remove 0 ones from the left hand side and 3 ones from the right hand side. If I have decided to remove 3 ones again, I can remove 1 from this side and the remaining 2 ones from that side. 2 ones from this side, remaining 1 from that side. 3 ones from this side and remaining 0 ones from that side. I can do things like this. Now, the point is, in the process, like these are the possible ways I can remove 2 ones. These are the possible ways I can remove 2 ones. And I need to see all possible ways. If any of them is giving me a yes, the answer would be a clear yes in this. Okay. These are the possible ways I can remove ones. And if any of them is giving me a yes, I would say yes, the answer is a yes. Okay. Now, moving forward. कैसे करूंगा ये ध्यान से देखना. This is comparatively a problem of very good standard. This is not a simple problem. This looks simple, but this is not. So what I can do is, now I need to consider all this. This makes up the basis of the intuition. Now I need to find a way where I can do this thing. So what I can do is, number of zeros removed when the first one is removed, that is 0. Number of zeros removed when the second one is removed, that is 2. The number of zeros removed when the third one is removed, that is, I would say, that is 4. The number of zeros removed when the fourth one is removed, that is 6. Number of zeros removed when the last one is 2, that is 8. This is just like building out the values at each point. So how would I so I would find this thing. How would I find it? I would simply do what? If the value, see, initially the value is 0, I encountered 1, I wrote it. Okay. Now let me tell you how am I building this. Okay. See, whenever I would encounter 1, I would write the value. Now let us see how am I building this. Or let's say, as of now, let's understand. Let's say this is number of zeros that would be removed if I remove the first one. 0, 2, 4, 6 and 8. Number of zeros that would be removed if I remove the first one, second one, third one, fourth one. Now, same I would do from that side. This is for prefix. Same I would do for suffix. From the suffix, if I remove 1, 1, 0 zeros would be removed. If I remove the second one, 2 zeros would be removed, 4 0 would be removed, 6 0 would be removed, 8 0 would be removed. Now, what I can do is, I would just count the total number of zeros. Total number of zeros is how much? 8. See, count of zeros, count of 0 is equals to 8. Now see how I would find the value. So if I have two values to remove, so like I would have the very first combination as 0 from the prefix and 2 from the suffix. 1 from the prefix, 1 from the suffix. 2 from the prefix, 0 from the suffix. These are the possible ways I can have. So if I remove 0 ones from the left and 2 ones from the suffix, 2 ones from the suffix means what? 2 ones from the suffix means 4 zeros would be removed. That is, if I remove 0 ones, nothing would be removed from the prefix. If I remove 2 zeros, 2 ones from the back, how many zeros would be removed? 4 zeros would be removed. So 0 plus 4 is equals to 4. Okay. Now, is 4 less than equal to 2? No. Now, if I remove 1 from the prefix, then 2 zeros would be removed. Okay. If I remove 1 from the suffix, 2 zeros would be removed. That is 0 plus 2. So how many zeros are remaining? Earlier zeros were 8. Now the zeros remaining is 0 plus 2, that is 2. That is 0 I have removed is 2. So zeros that is remaining is 6. Now 6 is still not less than 2. So 6 2 for this combination, this is not my answer. Now if I remove 2 zeros, 2 ones from the front, how many zeros would be removed? 4 zeros. So 4. If I remove 0 ones from the back, 0 would be removed. This is 0. So 8 zeros were there. We have removed 4 zeros. So the number of remaining zeros is how much? 4 only. So this is at no means 2 is our solution. By removing 2 ones, we can't have the value. Why? Because हमेशा number of zeros ज़्यादा हो जा रहे, which would make the maximum go high. Okay. Now let's try it for 3. Okay, let's try it for 3 at this point. So my pen broke at this point, or I don't really know if it's just the charger. So now at this point, let's say that we want to consider the value 3. So to consider value 3, what are the possible combinations I have? I have 2, I have the value 2, and I have 3. I have the value 1, and I have the value 2. I have the value 2, and the remaining values is 1. I have the value 3, and the remaining value is 0. So if I remove 0 ones from the array, I can't even write properly at this point. Okay, if I remove 0 ones from the array, the number of okay, if I remove 0 values from the array, I would get what? I would get 0. If I remove 3 values from the back, I would be able to remove how many zeros? I would be able to remove 6 zeros. So 8 minus 6 is less than equal to 3. That is why this would be my answer. फिर से explain कर देता हूँ. Basically in this prefix sum, we are calculating the number of zeros that would be removed if we remove the first one, remove the second one, and this is how we are doing. अगर मुझे एक अगर मुझे 3 ones, let's say for 3, if I want to consider it for 3, if I want to see how many zeros would be left if I remove one, let's say if I remove 0 once from the front and 2 from the back, then 4 zeros would be removed. See, 4 zeros would be removed and here 0 would be removed. Okay, if I remove 2 ones from the front and 1 from the back, then how many zeros would be removed? From here I would remove 4 and here I would remove 6. Now let us see this. If I remove 2 ones, I would remove 4 from here, I would remove 1 from here. This is how 6 zeros would be removed. So I would see if the I would fix the number of ones that is removed and I would see if the remaining zeros are less or not. If the remaining zeros are left, if the remaining zeros are less than equal to the number of 1 that is removed, I would say this is possible. If every time this is more, it is not possible. Okay? And how we are making up this array, this is also important. So what I am doing is, I am making, this is on the simpler side, I can explain this with my hand. Today I'm just writing with my hand, if you observe. Okay, so now see, I initialized a counter of 0. I came here, I came here at this point, I saw a 1, so I just pushed whatever is there. Then I increase I saw a 0. When a 0 is seen, I increase the counter, that is 1. Again I see a 1, I would increase the counter to 2. Again I see a 1, I would insert 2. Then again 4, 5, I see a 1, insert 4. Then 5 and 6, again see a 1, insert 6. 7 and 8, again see a 1, insert 8. I would do the same thing from back also. See a 1, insert 0. Then if it is 0, keep incrementing the count. Saw a 1, insert it. Then again saw a 0, increment the count, then insert it. We would do the same thing from the back and the front. So where it is this, I would show you that. So see, here I am doing it. First I am counting the zeros and ones on the string itself, and then if the value is 0, I would increase the count. If the value is 1, I would insert the count. So this would give me, if one is removed, if 2 ones are removed, how many 0 would be removed. This count would be given by this. So now I would do the same thing from backward. So see, the code is absolutely the same if you observe. This if state, this two loops are this loop and this loop is absolutely the same. We are just from the front to calculate the prefix, from the back to calculate the suffix. Then how we are calculating if possible? So how many values we need to remove? We need to remove mid values. So first I am removing I values from this side and mid minus I values from the back. That is why mid minus I value. If the leftover number of zeros is less than what we thought of as an answer, then we are taking this as possible is equals to 1 and breaking out from that. If this is not the scenario, the leftover ones are more, that would maximize that thing, so that answer would leak out. So that is why that is not possible. So I have already shown you this, and here we are using the prefix and the suffix thing to calculate this. I would subscribe you. I would kind of like, I don't, so if you have understood this, give me a 0 or 1 in the chat. And I know that no one was here till this point, and the view count is absolutely very less if I observe. So if I made sense to you, so there's no point in waiting. So still I would just float my solution at this point. Or if you want the solution, consider asking me this solution over LinkedIn. My username is Siddhartha Hazra. Siddhartha. HZRA. But consider asking me the solution after you have commented on the video. Okay, if you want the solution in the written, consider commenting on the just giving you a task. And I don't want to do this. If you want, I can give you a solution here also. Whereas no one is replying, so I'm just trying to increase the engagement and justify this work. So that was it from my side. I tried my level best to understand, make you understand the last problem, which is a very good problem in my view, to make you understand the last problem. And this was my way of solving it. There are multiple ways of solving it. If you want the solution, consider pinging me on LinkedIn. I would give you the solution, but after leaving a comment. So if you were here till this point of video and you liked my explanation and you think that yes, Siddhartha Hazra should be the one who should be explaining the Geeks for Geeks Weekly, or this has been done good, consider leaving a comment on the video so that I know that I was not teaching myself the last question. The hard work that was done for the last question was not just for me, it was for the community. So just give back to the community. I would just say that because it is free, of course. So that's it for today. This is what I can say. No replies at this point, so I would consider turning myself off as there is no point in waiting. That's it for today. Thank you and have a nice day, and all the best for your next weekly contest. Goodbye, everyone.